Okay, you guys, so the first thing, if you guys would, I think this is what, the second or third page of our notes. I made a mistake in the function that we have. So it should be 3x cubed plus x squared plus 3x plus 1. So scratch that out and put this new one in. Again, we're trying to find the zeros and then in the process break our polynomial up into linear factors. So our degree is 3, so I'm expecting 3 zeros, right? Some might be real, some might be complex. We're going to get there as we analyze the problem. It all starts with our PRZ list. So our factors of the last term are plus and minus 1. Our factors of our first term are plus 1, plus or minus 1, plus or minus 3. Doing the little divisions, we've created a laundry list of 4 possibilities. So again, go to our graphing calculator to figure out which one's which. So let me make this switch here. 3, that's 3x cubed. And what did I say? Plus, let's just get all that, plus x, squared. Plus 3x, and then plus 1. And let's delete all the rest of that stuff. Why is that not deleting? Delete, 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 delete. So 3x plus 1. Right, so I think I entered that right. So when I go graph this, we'll notice that it's crossing the x-axis, right? It looks like it's only crossing at one time. And so that basically tells us two things. One, this looks a lot like it's negative 1/3. So that's on my list of possibilities. So x equals negative 1/3 looks like the rational zero. And then since it doesn't seem to be crossing the x-axis anymore, that means that we do in fact have two complex zeros here, right? Because I do not see where they're crossing the x-axis. So they're not real, they're complex. So how do we figure out what these two guys are? Start your division process. So we're going to divide by x minus 1/3. And we're going to do that synthetically. Actually, that's plus 1/3 minus. List my factors out here. Bring the 3 down. Negative 1/3 times 3 is negative 1. That gives us a 0. Negative 1/3 times 0 is a 0. Bring down the 3. Negative 1/3 times 3 is negative 1, giving us a 0. So here's where we're at then. Our function, right, is the factor x plus 1/3, and then here's a quadratic. We have 3x squared plus 3. And I'll notice at this stage they have a share a common factor of 3, so I'll pull that out, and we're basically looking at that. So there's our function. So we found one of the zeros, and I've started to factor it. But one of my factors is quadratic. So where do these two complex solutions coming from? From that quadratic. So let's go solve it. When does that equal to 0? In this case, I can probably make use of the square root property, and we get plus or minus I. So our three zeros are negative 1/3, I, and negative I. And then in terms of factoring and linear factors, we have 3 x plus 1/3, and then that's x plus I, x minus I. And there's my 3 linear factors matching my 3 zeros that I got. All right, so we're all settled and ready to go. All right, the next one's a really big problem, right? We have degree 6, and so again, a lot of things going on there, but the process remains basically the same. We start by finding our PRZs, and in this case, factors of negative 16, well, plus or minus 1, plus or minus 2, 4, I think 8, and 16. Factors of 2, plus or minus 1, plus or minus 2. So our list, if we divide by 1, we just basically have that list of numbers. And then if we divide by 2, I think the only new one will be a half, because 2 divided by 2 is 1, 4 divided by 2 is 2, 8 divided by 2 is 4, and 16 divided by 2 is 8. So we have 2, 4, 6, 8, 10, 12. We have 10 possibles. So again, rather than doing a whole bunch of work here, why don't we just go turn to our graphing calculator. Let's make sure I typed in this right. 2x minus 11x plus 24 43, 44, yep, looks good. All right, so when I go graph this one, we see that it's crossing the x-axis. Uh-oh, maybe I need to zoom out. Oops, you know what? Maybe I didn't turn the, oh, there's the problem. I didn't turn the function on. All right, so highlight those equalities, turn it on. How about I zoom standard? Let's go back to our standard viewing rectangle. And now that I got the function on, hopefully it's going to graph here. Whoa, okay. So it looks, how about we zoom in this area? 1, 2, 3. Looks like x equals to 4 is one of them. But why don't we go ahead and let's go ahead and go to the window, go from -5 to 5, and then go graph it. And so we see that it looks like we have a 0 here, something going on there, but we definitely have 4 there. All right, so we're expecting, how about I zoom in a little bit more here, zoom in. Let's go zoom in and see what's happening right around that area right there. So it looks like it comes up. Yeah, so it might have a multiplicity of 2 there at 1. So we're looking at this function, right? It looks like, let's go ahead and, oops, window, go from -5 to 5 again. So when I go graph this, looks like it's looking at our list. It looks like one of them, I'm going to say that is x equals -1/2. We have x equals to 1, but of multiplicity 2, and then 1, 2, 3, 4. It looks like x equals 4 of multiplicity 1. So we have x to the 6th, so I'm expecting 6 of them, and 4 of them are accounted for just by their multiplicities. So this means that there's 2 complex zeros that we're essentially looking for with regard to this problem. Okay? And I already realized that I'm like 8 minutes into this. So how about, I'm going to stop here. We've kind of set the stage up. We're going to be doing a lot of division, but I'm a little worried that this video is going to get a little too long. So let me stop there, and I'll come back and I'll finish this particular problem off now that we have everything squared away. Be right back.